Hello everyone, and welcome to another live stream in which we're going to solve Project Euler challenges using JavaScript. For those of you who didn't join the first live stream we had, I think 2 weeks ago, we solved the first 4 problems using the freeCodeCamp platform, and in this stream we're going to solve a couple more. We'll see how it goes and how many we can solve. If you join the live stream, I can see close to 100 people being live. Say hi in the chat. And yeah, keep in mind that I didn't prepare for this problem. So while I don't have the solution, well, I looked over to see how it looks and how it works, how it should work, like a main idea, but I didn't solve them. And that's because I want to show you how you can even fail when you start doing something, you start coding on something, and that's perfectly normal. So yeah, we're going to try and solve this on the first go and see how it goes. For those of you who don't know me, my name is Florin Pop. I'm a developer from Romania. I have a YouTube channel where you can find me live coding almost daily, and I also upload different videos, or you can follow me on Twitter if you want. All right, I see Quincy. Hello Quincy. Good. So yeah, I think you can hear me. Let me know in the chat, and we can start with the problem number 5, the smallest multiple. Let's see what it requires. Smallest multiple. 2520 is the smallest number that can be divided by each of the numbers from 1 to 10 without any remainder. What is the smallest positive number that is evenly divisible by all of the numbers from 1 to n? Alright, so we're having to deal with divisible numbers. Okay. Yeah, also as Quincy mentioned, the chat for now is for members only. If you want to join the chat and be able to chat with me and engage, consider becoming a member. You also support this awesome platform and help other developers learn how to code for free. All right, so let's see. We need to figure out how, probably this one of the problems I wanted to solve today is the hardest. And that's because, we could go, so we need to get all the numbers from 1 to n. And then we need to find the smallest number which can be divided by each of these numbers, right? Now this could be trickier. We could just start and multiply 1 with 2 and 3 and 4 up to n, but then we'll get a very high number, and that's not the smallest number possible. I know that there is a function, I knew about it, but I kind of forgot, in which you could check you could have 2 numbers and check which is the lowest common multiplier. Let's Google it and see. Lowest common divisor. Yeah, I think, yeah, LCD, I think, or not? Denominator, let's see. Or, So this could be one approach to use this function, although I can't see it now. Or we can go the brute force and start with a number. Well, actually, let's do that. We're going to have one number to start with, and we're going to increase this number and check for every number if it's divisible by all the numbers from 1 to n. And I guess the starting number could be n. Hey Cataline, welcome to the live stream. How are you? Okay, and now we kind of need another function to check. Thank you, Cataline. To check if the number we're going to give it is divisible by all the numbers. So let's write check divisors, and we'll get the number and the divisors. Well, this is kind of interesting because, well, these divisors will be also number we're going to loop. Or all right, well, let's go with this, and then we can slowly improve the function. So here we're going to go from let I be divisor. Well, it should be I1. Then it will go I less than equals to the divisor. Hey Shan, thank you for the super chat. Well, thank you on behalf of freeCodeCamp, obviously. All right, so let's see here. I don't like the names here, so maybe number to check and number. All right, so let's do this, and here we can check if Cataline, thank you for the super chat. Okay, so if our number, well, I modulus number to check, so if this is different than 0, so that means it's not divisible, then we want to return false, right? So think about this. We're going to start with a number, which will be the biggest number here. Yeah. Okay. let's continue. So we're going to take, for example, let's write the examples here. It will be easier to explain. So we have the numbers from 1 to 10, right? And we need to find the lowest, the smallest multiply for the smallest number that can be divided by all these numbers, right? Which we know that is 2520. And what we're going to do here is we're going to start with 10. And then we're slowly going to go up. 10, 11, 12, 13, 14. And we're going to check all of these numbers if they are divisible by all the numbers from 1 to 10. Hopefully that makes sense. Let me know in the chat if it does or if it doesn't. All right, so that's what we're going to do here. We're going to have a while loop. I'm not sure if the while loop should be the best way to go. We might get an infinite loop, but well, let's try for now. Yeah, see, they say that it's an infinite loop. Well, actually, we could have a boolean found be false, and while not found, then we can. Oh, also we need to. We're going to use a start. So while not found, we're going to check divisors. We're going to pass the number to check, which will be the start, or what? Start is again not a good name. So let's write number to check. All right, so we're going to check the number to check, and we're going to pass in the n, which will be our number. Then here, infinite loop hype. If this returns true, then we want to, found be true. So we're setting found to be true. Well, again, it says that we have an infinite loop. So I don't know if this is the best approach then. Well, let's see how it goes. As I said, this is probably the hardest of the ones we're going to do today. So let's see again. We have the number to check starting with the highest one. All right. Then we're going to pass in the number to check. Oh, and here we want to do number to check plus plus, right? We want to increase the number, and at the end we're going to return this. Okay, so we're getting the number, we're checking for divisors. If it's divisible by all of these numbers, well, here we need to return true. If it doesn't find a number which is not divisible, then it should be true. Okay, and yeah, this should probably work. Although, let's check. It might run, might time out. Yeah. So something is not okay. Good. Yeah. If you're in the live chat, if you have an idea, feel free to suggest. Okay, let's think again. Will this check divisor work? So we have I1, I less than number, I plus plus. Okay, so we get the numbers from 1 to 10, for example. If we have the number 10. Okay, well, you know what? Let me see. So we need to check all the numbers. Okay, number to check. Oh, my bad. So the number to check has to be divisible by I. Right? Yeah, kind of messed it up there. Okay, let's also console.log this to see what we get. Okay, number to check 20, which is good. So we're passing 20. We need to check all numbers from 1 to 20. All right, and here we're saving it to the number to check. Now let's see if the while loop works. Okay, so we get this number, which is not what we wanted. Why is that? Isn't it? Number to check, modulus I different than 0, so it's not. Okay, what we get for 5? We should get 60. We get 61. All right, good. So we're kind of closer here. We get 61 because we increment here once again. So we kind of want to do it here. All right, good. So now we know at least one test will work. If we don't have... Whoa! That's nice. I didn't expect this, to be honest. So apparently all of them work now. Yeah, this is the life of a programmer. It works and you don't always know why. But yeah. You have a nice goal there, Catalin. Okay, so could we improve this? Should we try to improve this? Or we should just leave it? Yeah, so we're kind of checking all the numbers, which is not always. Oh yeah, I think that number to check, which we did there, could be number to check should be here. Although now, if we have a number like 2, it will say 4, and that's not good, right? Because we're starting with this number, but then we increment in the while loop. So I kind of want to do n minus 1. Okay, so now we get 2. Sorry. Yeah, what about 3? 3 won't work. 4. For 4 we should get, let's see, not 6, not 8, probably 12. Oh, look at that. Yeah, 12. So yeah, this works now. My throat. All right. So let's run this. Let's submit and go to the next one, which hopefully will be easier. We did it the brute force way, which is not, well, always the best solution, but if you don't have another solution, it should work. All right. Problem 6. Sum square difference. The sum of the squares of the first 10 natural number is 385. The square of the sum of the first 10 natural number is 3025. Hence, the difference between the sum of the squares of the first 10 natural number and the sum of, and the square of the sum is, well, that number. All right. Find the difference between the sum of the squares for the first n natural numbers and the sum of and the square of the sum. That's interesting there. Good. So yeah, basically, again, we need to take all the numbers from 1 to 10, or well, 1 to n. We need to add them up and then raise them to the power of 2, or we need to raise them individually to the power of 2 and then add them up. And the result of these two, well, we need to subtract. So yeah, this shouldn't be that hard now. Okay, let me see. I could, oh yeah, that's better now. Good, so let's create two functions. One will create the square of the sum, and one will create the sum of the squares. So function square of sums, sum. Okay, and function sum of squares. Okay, good. And both of them receive n. We could create an array and use the map and then reduce. So yeah, I'm kind of overcomplicating it now. Let me also add console.log here so we can see what we get. All right. So we need the sum of the so the square of the sum minus the sum of the squares. Let's go here, sum once more, so square of sum of n minus sum of squares of n. All right, not a number. Good. Now here, well, for 1 we need let I equals 0, well, I equals 1, I less than equals n, I plus plus, and square of sum. Yeah, we're going to have a sum, which will be 0, and then sum plus equals I, so we're getting all the numbers there, and then we're returning sum for now. We need the square of sum. So we can do either met.pow sum and 2. Let me return here 1 so we can see something in the console. Or we can do, I think this is a newer thing, never used, well, I didn't really use it. We can do this, which is pretty much the same thing. But yeah, this is more obvious that we're raising the sum to the power of 2. Good. Now for the next one, well, we're having pretty much the same thing, but instead of adding, so let's return the sum. Instead of adding I here, we're going to add met.pow I to the power of 2. So we're squaring the numbers. And yeah, this should, yeah, it looks like it works for 100. This should work. It's brute force. I'm not sure if you can do it the other way. I know there is a formula for adding the numbers. I've learned that in high school sometime. For adding the numbers from 1 to n. It was something like, let's see if I remember. So n times n plus 1 divided by 2. So this should be the total. And here we can do, whoa, wait, not here. this will work here because we're adding the sum. Yeah. Oh, not n times n plus 1 like this. See, so this works. Basically, I remember that for the numbers from 1 to 10, it was like 55. So yeah, this is the formula. And well, we don't have to do the loop, which is good. We saved some time here. We can also put this here. Well, let's leave it there. We can use const because we're not reassigning. Good. Now, about this, let's search sum of square formula. Sum of squares formula. Why not? Let's learn something new today. Okay. n plus 1 to n plus 1 divided by 6. All right. Thank you, Google. So this is the formula. Let's use this. So we kind of don't have this here. And this will be 2 times n. All right, let's return this. And here this. N is not, oh, sorry. So n is not a function. We need to multiply there. And here also. All right, so yeah, this is, I think this is now the more cleaner way, I should say, of doing this. We're using formulas instead of looping over, which is pretty good. It's way faster this way because we're just multiplying instead of looping. Because if we had a big number, well, then we'd have some problems there. All right, so yeah, let's submit this and go to the next one. Problem 7, 10,000 first prime, I think. By listing the first 6 prime numbers, 2, 3, 5, 7, 11, and 13, we can see that the 6th prime is 13. Okay, what is the nth prime? Ooh, nice. Prime numbers. Okay, let's see. So first, well, we could do again the brute force method and go over all the numbers from 1 to x. Well, this case is n, but we want the nth prime. We don't want to go up to n like we had before. So we can start again and check all the primes, get the primes, and store them inside an array. And when we get to an array of length of n, we're going to output the last one. This is the first idea I had. Let's see if that works. Although this is again the brute force. But maybe we could improve it afterwards. Now, let's see. So we're going to need let number, which will start from, let's see, so 2 is the first prime number. Good. And let primes will be an array. And I'm going to put a number inside because, well, 2 is already a prime. All right. Well, this could be a const because we're pushing to it. Okay. Let's see. And here, well, we can already do primes.pop because pop sounds nice and, well, it will return the last one. And this is what we want. What's the nth prime? Okay, and we can do a while loop while primes.length is less than n. So while we don't have the primes, we want to, well, push to the primes. So primes.push the next prime number. Okay, let's think here. How do we get the prime? So we could loop and find the primes. Yeah, let's do that. So we're going to, well, we have the number there, right? The starting number. And here we can do a check of it if it's a prime. So if is prime the number, then we want to push to the primes array. Okay. I guess then we can remove it from here because automatically two will be added. At the end here, we're going to do number plus plus. And we kind of just need a prime is prime function now. So how do we check if a number is prime? Well, a function. Yeah, there is a thing I'm thinking now we could do to improve, because only two is the only prime number which is an even number. All the rest are odd numbers. Yeah, English sometimes. So we could do numbers plus equal to just so we can save half the loops count. So let's do that. We're going to push 2 here and we're going to start from 3. So now we don't check for all the numbers, we just check for the odd ones. Okay, good. So that's an improvement. It will also probably not work for well, it will probably time out. Who knows? Depends on how long it will take. Good. So is prime. Let's write a function which will take in a number and it will return if it's prime. So return through here. By default, we're going to assume it's prime. And here we're going to do a check. So we need to start from 2. Let's go up to the number I++, and here we want to check. So let's see. We're going to start with 3. It will check the division. So if number modulus I will be 0, then return false. Because the one number is prime if only is divisible by 1 and itself, right? So we don't want to go up to the number, well, inclusive the number. Okay, and we check. So we go here and we check, is it divisible by 2 with 0 reminder? If it is, then, well, it's not a prime. Then we go up one more if it's divisible by 3, and so on and so forth. Okay, we again have a potential infinite loop. But this should work now. So we're checking if it's a prime. If it is, well, we push it here in the primes array. And when the primes array length is equal to n, we get the nth, right? Let's see what we get. Let me console.log this. Okay, so for that we get that number, which is not correct. Let's see what we have in the primes array. Okay, so 2, 3, 5, 7, 11, 13, 17. Okay, it looks like we have the prime numbers. Well, let me use it for 6. Okay. So if you do pop here, what happens? We have 13, which is good. Let's see, for 10 we get 29 the last. Yes. For 100 we get 541. For 1000, let's do pop here again. Okay, so somewhere around There it fails. Let's run the test and see what we get. Now that's weird. Why did they get that? It shows correctly now, but it didn't. Let's see again. For 2001, we should get that number. But we get this. That's interesting. It might be something here. Yeah. So it kind of stops in this terminal or whatever it is, but it works while we're running the test. Okay. There are a couple of things. Well, a couple. I have one idea which we could improve. You can see here that we're also going again over all the numbers, which is not okay. We also need to do something like we did here to skip, well, at least we could do to skip every 2 numbers. So we could do here, if number modules 2 is 0, then return false. This is for the base condition, the 2. And then here we could start with 3 and oh wait, no, I'm wrong here. So yeah, we need to go over all numbers because we could get a number and divide. What will happen here? We won't check for even numbers, right? So there's no way in trying to check with another even number. Okay, so yeah, that should work. Let's see. So this is what I wanted, to save more loops here. Let's see this. Okay. Yeah, although it took more time, which is odd. But at least here, you can see here we now got the number, so it's faster. Okay, and I think we also don't need to go up to the number, we can go up to the square root. We did it the last time. But I forgot again. So let's see. Yeah. No. Again, up to the square root. Yeah. So that works also. We don't go up to the number, but up to the square root. So we save even more loops. All right. So I think that's it for this one. Let's go to the next one. We still only have 1% completed. All right. Ask me later, please. Okay, problem 8. Largest product in a series. The 4 adjacent digits in the 1000 digit number that we have, the greatest product are 9 times 9 times 8 times 9. Largest product in a series. Okay, so we have this big number and we need to find the n adjacent digits in the 1000 digit number that have the greatest product. What is the value of this product? Alright, so yeah, we're getting a number and we need to find a number. We need to find a number which is n digits, and 8 digits is the highest product. Thank you, Quincy, I think, for supporting the organization. Yeah, should donate. Well, I am a member on YouTube, so see, I think I have I had the emoji, but I don't have it. I don't see it now. Nevertheless. Okay, so what we need to do? We have this array which they provided for us, thank you, which is good because it's already an array, so we can work with the numbers. And if we have a number of length, well, if the n here is 4, we need to check this 4, store the product, then check this 4, check the product if it's bigger than the previous product, and so on and so forth. Up to here, right? Okay. We need to get those numbers. If we have 5 numbers, we need to check like 5 numbers every time. So we can do that using, well, we again need to go over all these numbers, right? So all these numbers, and get the pair of 4 or 5 or 6 numbers, or how many they are. We can do that using the slice method. We can start from the index and get the slice or the splice method, but the splice will change this array. So let me first move this from here. I'm going to create it here, const 1000 digits. Okay, so we have room here. Next up, we want to create a loop which will go over basically all these digits, right? Don't worry, Catalina, I knew it's a joke. Okay, so it goes over all the digits, it will get the pairs and check the next one, and so on and so forth. So, well, let's do that. For let I is a 0, I less than n for now, but we're going to change this, and I plus plus. Good. And here, take the pair, it's not a pair, how do you call when it's multiple? Take the series, whatever, and check the product. Here we're going to store the maximum product. So max product will be the lowest number possible. So yeah, let's put 0. And we're going to check if series product is greater than max product, then we want to do max product be equal to series product. Okay, this is the function we're going to create. Okay, good. Now, because we're calling it twice, well, let's move it out in a variable. So const product will be series product. And here we're going to pass in an array with all the numbers we want. Okay, good. And at the end, we're going to return the max product. Let's console log it again. All right, now the only thing it's left, we are left to do is to create this array. So we want to get n numbers at a time. So starting with the index, we can do that by, let's see. So we have this array. Well, let's write it here. Array will be this, that's slice. Slice needs the index on which you want to start, so it will be I. And the second argument will be, or parameter will be the index you want to end, but not inclusive. So we want to do I plus n. So let's see, if we start, this will be 0. If we do I plus n, which is 5, we're going up to 5, but not inclusive. So we basically want to get all these, right? 7, 3, 1, 6, 7. And slice will give us this 4 because it goes up to. So we can do I plus n plus 1. And now it will take all the 5. In the next loop, it will start from this one and take all the 5. And then this one, and so on and so forth. We're going to pass this to our series product. Yeah, let's write it here like another function. But then afterwards, we're going to write it in line. So function series product, we get an array. and we want to do the product of all the numbers. We can do that using reduce. So array.reduce, which gets an accumulator. We're going to store the product in this accumulator, and we have the number. And we want to return here accumulator times equals to the number. And the initial value should be 1. Okay, 1000 digits. Oh, yeah, it's a const. It doesn't see now this because it's a constant, it's down there. All right, let's put it up. All right, good. Okay, cdx product, array reduce, accumulator times number. This should work. We create a new array. Now, again, the last thing wanted to check. So basically now we're going up to n, so this one. But after this we don't have five numbers. So we could go up to n minus, oh, this is up to n, sorry, not up to n. My bad. We need to go up to 1000 digits, that length. So the length of this. And we can subtract the n, so not the last ones. Let's see if this works like that. All right, yeah, so definitely not works now. Let's see for 4 what we get. So yeah, that number. Now the bad part is that we can't really debug this because it's a long list. So let's see. We have this array, we have the max product, start with 0, we return the max product. That's fine. Here we're going over all the numbers. Sorry, we're going over, yeah, the digits, and we're slicing the digits we need. Thank you, Quincy. Yeah, I hope people enjoy it. So we're slicing from I to I plus n plus 1. So the length plus 1 because it doesn't go to the end. Good. Now here something happened. We're going to the length, up to the length minus n, minus 5. Well, basically we want to check the fourth. Well, if we check the last 5, we want to go up to this number, right? So it's minus n, this is n, plus 1. So we need to check this and with his friends. So plus 1. Okay, but we still don't get the correct number. Well, or do we? No, we don't. Good. Next we have this product, which is array reduce. Let's I'm thinking, how can we test this? Because if we do here count something like count.log product, just so we can see we get a lot of numbers. Well, I guess we could try deleting these. Or you know what? Let's comment this out. And let's write again just with a couple of numbers so we can check what happens. All right, so we have 1, 2, 3, 4, 5, 6 numbers, and we want to check, let's see, the pair of 3. No, let's leave it 4. So basically these 4 or these 4 or these 4 are the largest. Now we kind of need to see what we get the product. So console.log product, and let's also, so product, let's also see the array. Okay, so we see that we already have some issue here. we get 5 numbers and we only need 4. And so plus 5. Oh, yeah. So my bad here, we don't have plus 1. The logic was correct, but the implementation was wrong. So if we start here, this is I, and we want plus 5, so 1, 2, 3, 4, 5. But then we added one more, yeah. So this already goes up to the number we want, plus 1. All right, my bad, good. So this should work now, hopefully. Well, yeah, let's see. So we get these numbers and we get it, the maximum to be 126. And we also, you can see how nicely we get all the pairs here. If we add one more number here, like 9, we always get an array of 4 numbers, which is perfect. All right, let's comment this out. Let's remove this. And look at that. We have the number 5,832. Let's run this, and yeah, and we got to 2%. Awesome. Now, what could we improve if we could improve something? One thing would be, well, I created this function, but we kind of... hey, Laurent, how are you? Welcome. We kind of can, well, we could do this here, right? It's just a function calling reduce. So we can do that there. All right, but other than that, I don't really see how we could improve it. Well, when you're working with this, the way you should think about how to improve it is when you have a loop, right? You want to see if you could somehow not have a loop or have less iterations. But I think for this one should be fine. You wish you could code, Catalin. Oh, I think you can code. Yeah. So we kind of need to go over all the numbers. I don't think we can cheat somehow. I don't really think. Yeah. I think this is the approach. Maybe someone can find something even better, but I can't for now. All right, let's run this and submit. And there we go. The 7th done. Whoa, the 8th. Really? When did we start the date? All right, let's go to the 9th then. All right, let's drink some water. We need a bit of a break. Good. The 9th problem, special Pythagorean triplet. Hopefully I pronounced that right. A Pythagorean triplet is a set of 3 natural numbers. Sorry. A less than b less than c, for which a squared plus b squared equals c squared. Yeah. Yeah, this is another math-heavy-ish problem. So for example, 3 squared plus 4 squared is 9 plus 16, which is 25, which is 5 squared. So this is a Pythagorean, well, 3, 4, and 5. It's called a Pythagorean, well, triplet. There exists exactly one Pythagorean triplet for which a plus b plus c equals 1000. Find the product ABC such that a plus b plus c equals n. Okay. What? We need 3 numbers which are Pythagorean triplets. Well, part of Pythagorean triplet. I'm going to mess this up a lot, saying Pythagorean. And when we find them, we need to check if their sum equals to n. And then we need to multiply them. I'm not sure. Did I understand this correctly? So there exists exactly one triplet for which a plus b plus c equals 1000. Okay. Find the product ABC such that, oh yeah, so the product ABC, this is a product, okay, such that ABC equals n. ABC equals 24, the product should be 480. Oh, okay, so ABC, but here we have a squared, b squared, c squared. Okay. Yeah, couple of things to check. Here we have a plus b plus c will be, let's see, 3 plus 4 plus 5, 9, 12. Okay. What would be for 24? Oh, I think a way we could do this is to... I have 3 loops in mind, like 2 inner loops. One going from for A, one for B, one for C, and then for C going up to a number... Yeah, thank you, Cataline. Have a good day. Now, yeah, I'm not. But thanks. Let's see. So I'm going to write something just so we have a starting point. For let I, not I, a equals 1, a less than something, maybe n. Well, I said a, but I wrote I. A, no, I plus plus. All right, and here, well, let's go for B and C. B and C. Now, B has to, we have this condition here. So B has to be 1 bigger than A at least, and C 1 bigger than B at least. So we can do here B equals A plus 1 and C equals B plus 1. All right, now we need to check if they are Pythagorean triplets. So if is triplet ABC, if it is, we need to check its sum. And if we find the sum, we can return the... So if we find the sum to be equals to this number, then we can return the product. So let's see. If it's a triplet and A plus B plus C equals n, right? Yeah, let's put this here. Then we want to return A times B times C. Okay, this is not sum of ABC. Yeah, not sure why I did add it there. And we don't need this. So we kind of do everything in these loops, although I don't know if it's the best way. But yeah, so we go up to the number. Now again, we go up to the number, but we probably shouldn't because, well, the number in this case will be 24, but we kind of need the sum to be 24. So it's obviously that 3 numbers which are greater than each other, they can't add up. They can't all go to 24. So yeah, but that's an adjustment we can fix later. Now let's create this is triplet function. So function is triplet. We get A, B, C. And let's see. So we need to check if a squared plus b squared equals c squared. Return a squared plus b squared equals c squared. Potential infinite loop. Yeah, it shouldn't be infinite loop. Not sure why they said that. We're not reassigning. See, so yeah, should be good. Let's see, console.log this. Although this is not undefined. Okay. So a less than n if it's triplet, and if the sum, then we return. Otherwise, let's return one here. Just okay, and let's check for 24. But you can compute C out of A and B. Not sure what you mean. Okay, so for 24 we get a number, which is good. Now for 120 we get this number, and for 1000 hello Prashen, welcome to supporter role. So you saw that it works for 24 and 120, although they say this or this or this. But now for 1000, yeah, test timeout. Because, well, you can compute C out of A and B. I feel like you have something there, so we don't need to go another loop. I kind of have an idea of what you're trying to say. Let's see. So definitely this doesn't work because we have a loop of 1000 and 1000 and 1000. So that's a lot of thousands. But as you said, we can compute C out of A and B. Yeah. Yes. Yeah. So C will be N minus B minus A, right? That's what you mean. So then we don't need this loop. So then we're pretty fast. And look at that. That solved it. Thank you, Arendt. Well, I couldn't have done it without you. Yes, so we don't need to loop for C because we can find out what C is by doing the subtraction, right? Because we know A, we know B, we know N. Yeah, thanks. That's really good. Please stay around. I need your help. All right, it's pretty good, and I think now they're passing the test. Oh, such a good feeling. But yeah, let's think. I don't like the fact that we're going up to n, right? Because we definitely don't need to check for a to be n at any time. It could go up to at most n minus 2, right? So c could be no, definitely not. But how? So if we have a sum of 3 numbers be 24, what's the lowest a, well, the highest a can go? It can be something like yeah, I couldn't. I couldn't without you. You gave me this idea. It was very good. So if we have 3 numbers adding up to a number, how can we check what's the maximum value to that? So a could be for 24. So we have ABC equals 24. A could be 23, but then B and C, well, A couldn't be 23 or 22 because B and C needs to be higher, so definitely the sum couldn't be 24. Then A could be half, no way, because if it's half, then B is bigger than the half, and C is even bigger, so again, we don't need to go up to n, not even up to half of it. This will still work. Also, B doesn't need to go up to half of n. Again, of the same principle, right? So we have three numbers. Their sum is 24. Yeah, I think here we already saved a lot of loops, but I still need to see, could we find out how much they can get? I think 24 three numbers. So definitely, well, if we divide by 3 because we have three numbers, then yeah, that's an idea. So, well, I'm talking too much now. Let's write something. So we have 24. This could be something like 7 plus 8 plus 9, the most, right? Because 24 divided, let's see, 24 divided by 3, blah, 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 and here we get this. So A could go up to n divided by 3 minus 1. And this could go n divided by 3 like that. Up to, okay, so up to. Okay, we broke it. But why? This could be A divided by 3 minus 1, okay. B and C could be at most the third part plus 1. Okay, so we broke it somewhere. Let's see, for 24 it still works. Yeah. For 120, okay, so here doesn't, oh, this is the correct answer? I thought it's 49,920. Or is it all of the three? Yeah, I'm kind of spending a lot of time on this one, but I want to see if we could find the best approach. But it is the square root. I don't follow there, buddy. Don't follow you there. Yeah, so we only have a problem with 1,000, which gives us 1. So it doesn't find a triplet. So we broke it once we said here divided by 3. Trying some random numbers now to see. Yeah, so apparently it's not divided by 3. Oh, well, you know what? B could be pretty big. I made a mistake, so this is for A. A could be at most 7. But then B could be something like square root. Oh. I'm not. Yeah, that's for the triplet check, right? So this is for A. And for B, we need to see the maximum. So we kind of could do AB1, A equal 1, then B equal 2, and that leaves us to, oh, no. So B could be, yeah, let's test. So half 11, I think, and then C could be 12, right? they always need to be bigger than B. Well, C bigger than B bigger than A. So it could go up to 11, which is half. Yeah, that was my mistake. So A can go bigger than 7, which is a third. Well, one less than the third. And B can go up more than half. Well, also half minus 1 here. Yeah, kind of. I think if we put 2 here, it will still work in this case, but might break in other cases. Let's see. Yeah, so what I wanted to do is to find, to improve this, to make it as fast as possible. Who knows, maybe there are even better ways to check it, to do it. So yeah, here undefined, well, which is by default, so we can even remove this. All right, good. Let's go to the next one. We spent way more time to this. Problem 10, summation of primes. Primes again, all right. The sum of the primes below 10 is 17. Find the sum of all the primes below n. Okay, this doesn't seem that... Whoa. Look at this. This is a big number. We definitely need... we need to improve this. It might be a timeout if we do the brute force. But let's start with the brute force. So again, we need to have a function which will check if it's prime. Let me write it down fast. So let I be 2, I less than equal, well, less than med square root of n. We did this in the previous challenge, so I'm not going over it again. Well, I guess we could yeah, we could test here, and modulus 2 equals to 0, then return false. And here we could do 3 and plus equals 2. So we improve it even more. If n modulus I is 0, then we want to return false. Let me put this also like this, just to make it pretty. And otherwise, if we don't have this, we have a prime number, so true. Good, so we have a prime checker. Okay, yeah, this looks good. Now, wait a second, here we go. Yeah, it should go for 2. Okay, good. Now let's go over all the numbers up to n and find the primes and then add them up. So const primes will be, well, 2, and here let's have let current, or well, number be 3, while a number is less than n, we want number plus plus, and here we want to check if is prime number, then we want to add it in the primes array. So this way we add all the primes. Let's see, primes here, console.log here, and let's use a smaller number. Good, so yeah. Below 17 we have this. So find the sum of all the primes below n. Okay, so not inclusive. Good. Yeah, and we kind of need to add them up. So we could use reduce accumulator number, accumulator plus equals number, start with 0, and voila. I think. Not voila. It doesn't work. Why is that? Let's check for 10. We get 26, which is not good. Let's see what we have in the primes. 2, 3, 5, 7 and 9. Oopsie. Why do we have 9 as a prime? Oops, up to. So I less than equals to square root of n. Up to, well, inclusive. All right, this should fix it. So excited. Yeah, so we get 17, good. And fingers crossed, yeah, it works. Okay, so we have a function which checks the primes. Then we get all the primes, we put it in a primes array. Or you know what? We can even don't do this and just have a total be 2. And every time we find, we just do total plus equals number. Why do we do reduce here? Not sure. All right. Not number, total. Total is read only. Yeah, obviously. We need something like this. All right. So yeah. Is there a better way to test this? We kind of did the optimization here. So we don't go up to the number. If we would go up to the number, let's see what would happen here. So we go up. Let's not even check for 2. So I just want to show you that the brute force might not work. So we go over all the numbers, right? If n, okay, false, good. So let's see. Yeah, it doesn't work because I did something. Oh, okay, yeah. So we need to check for 2, not for 1. So yeah, this is the brute force. Well, the longest, and you can see that it will time out, I think. Yeah. So this is why we need to improve it by adding these small tricks. All right. Hope that made sense. So here, basically, we would go up to a number like, what's here? 2 million. But by doing this, first, we remove half of the checks by doing plus equals 2, right? Second, we remove, I'm not sure what's the square root of 2 million, but well, let's check. Console.log, man, that's square root of 2 million. Yeah, so we don't go up to 2 million, we go up to 4,000. So that's a lot of millions worth of loops, right? So you can see how fast it is now. Is it 2 million? Yeah, it is. Oh, okay. So I added here 20 million. So yeah, it goes only up to 1,414. And also it skips every other number. So it kind of does only 700 loops. And the brute force did 2 million. So you can see how's that good. Also, you could get this question in an interview. So it's good to know something like this, I think. All right, let's run this and go to the next one. Thank you, Laurent. Please please stick around. Oh boy. Now this will be complicated. Should we do this or go take a nap? All right, largest product in a grade. Okay, we did something similar, but it wasn't in a grade, it was in a row. So let's see. In a 20 by 20 grid below, 4 numbers along a diagonal line have been marked in red. Why? The product of these numbers is big number. What is the greatest product of 4 adjacent numbers in the same direction? Up, down, left, right, or diagonally in a given array? I don't know. All right, so now this is interesting. Okay, I see here we have an array of arrays. Yeah, it's pretty tricky. So we kind of let's go back to the challenge we solved. There was this largest product in a series, this one. Here we only had to go one way, but in this we need to go in a lot of ways. So we need to go to the right, to the left, up, down, and diagonally. This is fun, yeah, to watch. It's very fun to watch. Okay. So we have an array of arrays, which gets, the inner arrays gets the rows. Okay, we could, let's think. Could start by going like this, and well, do the same thing we did here. Do we have, no, we don't have the code anymore. Oops. We could have used that. So we could go line by line and check what we did previously, right? That will be going to the right and left, right? Because, well, it's the same thing. Up and down is the same thing. That's one approach. Well, we kind of need to do three things: to the right, down, and diagonally. To the right and to the left. Yeah, that's tricky. This will probably take up the remaining time. All right, so first we go like this, then we go like this, and then we need to go like this. And well, when we're here, we need to go like this and check all of them and store the biggest product. Okay, let's stop complaining and start doing something. Good. Too bad I didn't save that. I'm not sure why. Why I didn't save it. We could have used that. So we need to think. Basically, we're going to have a loop. Let I equals 0, I less than array.length, I plus plus. This will go on a column, and then let I j equals 0, j less than array.length, j plus plus. This will go from left to right, right? Right, good. So here we can go to the right by checking what we had. Wait, what's the 4 numbers? Okay, so the number, let length, or I don't know, n be 4. No, not n, I don't like n. We need to, so the length to check. It's a bit too long, but that's what we need to do. So here, if we check to the right, well, okay, so we can check like we did, right? So we get an array, which will be, well, we have array already here. So yeah, this is the grid. Okay. Let's write this somewhere else. Grid. No, we have grid here. Matrix. Yeah, that sounds better. So have the matrix. I'm not sure if that's the right thing, but all right. And here we need a subarray, which will be, by the way, here we need to go matrix of I, that length, because it's the inner array. The subarray here will be matrix of I that slice from j up to j plus length to check. Yeah, so this is what we did previously. And here, well, let's store the let max product be 0, and here we need to do if, well, const product will be subarray dot reduce accumulator number, accumulator times equals number, and we start with 1, and if product is greater than max product, then max product will be product. All right, we solved 1 to the right, which we basically had in the previous challenge. This is why I went a bit faster over it. Good. But now we need to go down. So how we do that? 2 down. Let's have another. Now the only issue here is that we're not, if you remember in the previous one, in the problem 8, we kind of we went up to this number and we checked the last 4, but now we go up to this number, which won't have, so the slice will only return this, but then the product will be, yeah, it will be just this number, so it shouldn't worry us. But if we go like this, if we end up here, well, sorry, here, we need to check 1, 2, and nothing. So that could be, let's see, could you see that? Yeah, okay. So yeah, here we don't have anything. And we need to check for that. And then we have the diagonals, which will be, okay. Good, so 2 down, 1 left. Let's do the brute force, and then we can see. So basically when we're here, we need this, this, and this. Oops, this, and this. When we're here, we need this, and this, and so on and so forth. So let's write this right array. Okay, and right product. And we do this for the right, and then to down. We need a down array, which will be an array with a matrix of I and j. This will be the current item, so this one. Now we need this one, which is I plus 1 and j. So matrix of I plus 1 and j. Then matrix of, well, let me put this here. So see, we go down on the row. The reason why I'm doing everything here is because I don't want to go multiple times over the entire grid. Okay, so I plus 2 and j, and matrix. Well, do you know what? It's not that hard actually, it's just a lot to type. I was worried for nothing. So yeah, now we have the down array, but this, well, this won't exist. Well, it could not exist. So if we're here, I plus 2 is nothing. So we don't have a j there. So we kind of need to check for that too. So if we have matrix of I plus 1, we want to get that. So do we have it? Or it could be 0. Okay, so how do we check? It's different than undefined. We get that, and otherwise we get, well, 1, right? The number well, in the product, if you have 1 and multiply with anything, it will be still the same number. All right, so think this is what we need to do for all of these. And if we don't have it, we just say 1. Okay, cannot read property 0 of undefined. Why? So if matrix side, oh, sorry, 2 and 3. Good, good, good. So yeah, now we kind of checked for those test cases. And yeah, let's do the same thing here. Const right product. I kind of want to move this in a separate function now. So down product will be down array and all that. So, whoops. You could create a down array with a loop 4 times incrementing the row I and checking. Yeah, but that's another loop, so I kind of did it manually here. All right, let me write a function get product, and this will get an array, and we're going to do this thing here. Return array reduce blah blah blah, all that. So now we get the product of down array, and here we get the product of right array. Whoops, oopsie. Get product of right array. Good. Okay, so now we're left to check for diagonal 1 and diagonal 2. So it's just a lot of typing to do, and yeah, more than it's hard. So diagonal 2, well, check to the right, check to the bottom, not sure if to the down is something. Check diagonal 1 and check diagonal 2. Okay, let's think. So we need to go from this and go like this, and so on and so forth. We always need to check if we get the indexes. Yeah. Okay, so here we have kind of a bit of a problem. Oh no. Yeah, it should be good. So we go like this from top to bottom right, and then from top to bottom left, from diagonal 2. I was thinking that when we're here we need to check this too, but we already have it if we go down that way. So let's see. So here we need to go down, and we get here we don't need to go up. All right, so yeah, we're going to need something like this here and here. This will be diagonal 1 array. This will be diagonal 1 product. This will be diagonal 1 array. This will be product and product. So many copy and pasting, and don't really, yeah. All right. Then we have, well, actually, you know what? Let me delete this, and I'm going to copy this and change the 1s to 2s. 2, 2, 2, 2, 2, 2. All right, good. Now, when we are here? This element is I plus 1, j plus 1, right? So I plus 1, j plus 1. We also need to check if we have that, right? Because when we're here, we don't have I plus 1 there. Now, the second one is I plus 1, j plus 2, I plus 1, j plus 3. Now, the issue is that we might not have this. And then we get undefined. I don't really want to do another ternary operator, although Yeah, this won't look very good, but let me do this just for now. So we're going to check if this equals to undefined. Well, not equals, different than undefined. If it does, then, well, we're going to add it. Otherwise, we add 1. So we're checking that, then we're checking that. Okay, what happened? Unexpected comma. Oh, okay, so this one. No. Oh, yeah, so another comma here. Yeah, this is a bit silly. So we're checking if we have the first. We have the I here. If we don't have it, then we want to put an 1 in the array. Then we're checking if we have this. If we don't have it, we put a 1 in the array. And if we have them both, then we put the number. Yeah, I'm going to think about a way to improve this. So this could kind of work. Let me put it 2 more times. And we're going to change. You could go only with the matrix length -4 for I and j. Yeah, but I still need to check. Yeah. Sorry, I don't get it that well now. So let me do that brute force. So we're going to swap that with 3 and this with, well, that with 2 and this with 3. Okay. So yeah, that's not good. Carry property 3 of undefined. Oh, okay, I see. Oh no, so it should be good. So if this is not undefined, it goes here. Checks this one. If this is not undefined, it goes here. Otherwise 1, 1. So why we get 3 is undefined? Probably I messed up something. Yeah, so this will be diagonal 1, and diagonal 2 will be, let me put it here. It's kind of silly, but yeah. So we're here, we want to go this way. So -1, -1, -2, -2, -2, -3. All the pluses here will be, all the pluses here will be minuses. Cannot read property -2 of undefined. Oops. Why do I get undefined? I don't see it. And yeah, here, well, if this if everything works, we should have the max product here, but it doesn't. Also, yeah, 20 by 20. Okay, so it's a square grid. Canary property -2. So here it doesn't look right. Oh, okay, I see. So I forgot to change the first part here, the first check. Okay, so I think we have it now, although these checks are looking awful. But let's, where it is? Let's console.log this. And we don't get a good number. Okay. There's no way. Oh, we could test on the test. Great. Although, yeah, again. All right, so what's happening there? I'm going to rewrite the test grid just so we can test. So we're going to have 999, 1, 1, 1. Copy this 3 times. Here we'll have 999, here we'll have 999. So we only have 999 on diagonals. Other than that, we'll have 1 everywhere. And we should get, oh, sorry. So let's put 2 instead. We get 16, which works. What happens if we add 1 more? So we should still get 16, okay. What if we add 3 here? We should get 8 times 3, 24. We get 24. So then what's wrong? What about if we go the other diagonal? Oops. 1, 1. Oh boy, this is so badly formatted. Don't like it, but nevertheless. 2, 2, 2, 2. Okay, so you can see now that it doesn't. Oh, let me format this because I don't like it. So it doesn't pick up this. Good, we know where is the issue. Is here. Oh, yeah, my bad. So it goes -1, -1, minus, it goes up, top, up. Top, yeah, top, up. Up and left. And we don't want that, we want down and left. So down, +1, down, and, well, this +1 again. Probably you're yelling at your screens now, but oh well. See, this is why it's good to debug and write this dummiest code example. All right, look at this. So we basically, if you're looking at this number, we went this way. So we went from 5 to 47, 31, and 0. And we needed to go from 5 to 69, 99, 62. Okay, that solved it. Let's see. Test grid. Okay, so I think that doesn't work because I changed the test grid. Yeah, probably. I don't know. Yeah, look at that. Oh boy. This was a tough one. Well, tough because we had to write a lot of code. Do I want to improve this? Yeah, I guess I could remove the space here, but that's all. I'm thinking. We have a lot of kind of copy and pasting and changing the values, and this check is, you know, not very clear. One thing you could do. Yeah, I have an idea. Let's try that. So instead of doing the ternary operator, we could do and here. So it's going to sec. Well, we need that instead of this actually. And we're going to do the short circuit method, and we could avoid now this. So if this is true, it will go here. If it is false, it will put false inside the array. That's what we want to avoid now. Well, we need to check here when you do the product. But yeah, that's another thing we'll need to worry about. Now, the good thing with this approach is that We don't simplify it a lot, but let's see here. So instead of doing this triple ternary, we could do matrix I plus 1 and matrix I plus 1 and j plus 1. Oh, again, so different than. So let's see, because the thing why I'm checking. Oh, this couldn't be 0, so it'll be just undefined. So let's try this. So it's going to check for this. If it's an array, it will be true. If it's not, well, it will be undefined. If it's undefined, it will be false, so it will, well, be undefined inside the array, which is good. So I think now we could do this everywhere, but just for simplicity's sake, let's comment it out and do the simple version first here. So plus 2 plus 3, and this was plus, wait, where? Plus 2 plus 3 plus 2 plus 3. And we get the same number. Whoa. Okay, I think I know why. So our product method here, so this number could be, I kind of only want to show you once, so how could I do that? So if we do here console.log array, hopefully don't break my, yeah, it won't break my my browser, but you can see that sometimes we get undefined. And apparently 2 multiplied by undefined, it will probably convert this to 0. And that's good, we get a total of 0. Well, let me check quickly here. So if we get console.log 2 times undefined, should be 0, not a number. Alright, so we get not a number, but then we do this, diagonal 2, which is a number. Is it greater? I think that's why. So we need to see why JavaScript works the way it does. So we need to check if 3 is greater than this, and it's false. So it's not greater, so it won't add it. Alright, works for me. Although the best thing to do would be to check if this number is actually not a number and convert it to a number, or well, to 0 if it's undefined. But the trick works, so let's not worry about that now. Good, so the last thing we'll do here, I'm going to copy this again if I mess it up just to have a backup. And we need to do this, and end. Yeah, look at how much code we save with that. Pretty crazy. Paste this in, plus 2 plus 3, plus 2 plus 3 minus 2 minus 3. All right. Yeah. Let me remove the test grid here, use this, get eventually that number. Okay. And remove this. So yeah, this looks much cleaner now. I like it. Goody, how we say it in our stream. Yeah. Let's submit, and it works. Now, the good thing is that we only go over the matrix once, and we check everything inside here. The only thing we could we could think of, let's see what Lauren says. So I was thinking, if you look at the number 40 in the bottom right, 40 in the bottom, okay, this one, then you see you do not need to go further than I equals 16. and j equals 16. Oh yeah, you're right. So we could do, I think, minus length to check. Although, no, not really. No, because we need to go here and check this diagonal. So we kind of need to go up until here. Hey Quincy, I'm glad you're still around. Yeah, goody. Yeah, you wrote it wrong though. It's goody. Yeah, that's our saying. Okay, so we kind of need to go up to 36. Well, we don't need to, yeah, we don't need to go on this row though, so that could save us a couple of checks. So length to check, right? No. Length to check plus 1. Yeah. So yeah, you were right. Yeah, you're right, Laurent. Yeah, nice. Clever guy. I like you. I like the way you're thinking. Good. So yeah, we could just go up to this row because it will go. Oh, but you know what? Then it won't check to the right here. And it won't. No. What if the number is on this row? We won't get it. So yeah, you know what? Let's leave it like this. We kind of need to check even this one right now. And that one, and yeah, this one here is diagonal, so we need to go to this number. We need to go to this number. Yeah, so this is we can't really cheat, so we do that, and we're using the undefined in JavaScript just to play around with it. Can I, if I do command save? Yeah, look at that, it's saved in the browser local storage. Good, if we need it. All right, let's see what's the next one. If it is too hard, well, if it's more complicated, then oh, whoa, I almost didn't submit. All right. Every direction has a preferred limit. Not sure what you mean by that. Sorry, I might just be tired. Okay, let's see what's this about, and if it's too, I guess we could try it. Highly divisible triangular number. Okay. The sequence of triangle numbers is generated by adding the natural numbers. So the 7th triangle number will be 1 plus 2 plus blah blah blah. The first 10 terms will be 1, 3, 6, 10, 15, 21, and so on. Let us list the factors of the first 7 triangle numbers, sorry. Okay, we can see that 28 is the first triangle number to have over 5 divisors. What is the value of the first triangle number to have over n divisors? Yeah. You know what? Let's leave this for the next week stream. I think I will have a fresh mind. Yeah, so basically we need to get all these numbers and then check the divisors. What's the value of the first triangle number to have over n divisors? Yeah. And you know what? Let's do it now. I'm kind of addicted now. Okay, so we're going to loop over all the numbers. I0, I is 1, I less than what? We don't know, so we need a while loop. While true. I don't like that. It will complain. But while true, we need to let I is 1. We get here. You don't need to do them all in one go. Yeah, I know. But at least do as many as we can. So we improve this. Well, we get I plus 1 at the end. And here, well, we need to check const length divisors. Or I don't know. Divisors. Again, divisors and prime numbers and all that. Will be an array, and we need to check here if divisors dot length. So let's see. What is the value of the first triangle number to have over n divisors? So if it's greater than n, we want to return the number, which we don't have now. So let's get the number, constant number. I think this will be triangle number. Triangle number would be get get triangle value, and we're going to paste in I. So this is the number, right? Okay, and let's write that function get triangle value. I didn't wrote it right here. For a number. And here we need to go up to that number and add all the numbers. So one way we could cheat, kind of. Well, let's do a for loop. Let sum equals 0, for let I equals 1, I less than equals to number, I plus plus, sum plus equals I, and return sum. All right, so we kind of get these numbers, right? So for 1, we have 1. For the number 2, we have a triangle number of 3, so 1 plus 2. For 6, we have 1 plus 2 plus 3. I kind of see a pattern here of a way we don't need to do this, but well, we'll get that in a moment, because we basically have the sum already. We just need to add another number, so we don't need to do this loop over and over. All right. So we get that triangle number, and now we need to get the divisors. Let me put this here and write the function get divisors of triangle number. Function get divisors do, yeah, 1 count of number, and here, yeah, I wanted to reduce. You know me so well. So we need const divisors, an array. We want to loop over all of them. I is 1, I less than equal to mat.square root of number. I plus plus. Yeah, I kind of see something we could improve here. Nevertheless, oh, we need to go up to the number, or we could just add it. Yeah. Oh, okay, so no square root. My bad. Let's go up to the number. And because basically number. Here we need to check if number modulus I is 0, right? If it is, then divisors push. We don't deal with primes. I had primes in mind. Push I. And here we want to return the divisors. Goody goody. I want to check for 5 though. Good. And triangle number, I want to console.log. Let's see what we get. Whoa, we got it. Look at that. Will it work for all of them? Timed out? Probably. But we have an ace we can use. We have an ace in our sleeves. Not sure if that's used in English, but in Romanian we have that saying. Good. So the issue one thing. Okay, so I kind of see a pattern here. It goes up to the number, the half of it. So up to half of the number. This is one improvement. Oh, yeah. So we kind of have 1 by default. We need 2 here. And divisors that push, we need to push the number at the end. Because we're going up to the half. So then we don't have the number itself. Although if we have 1, we don't only want 1. So that's a special case. So if number is 1, return 1, an array of 1. So this is special case for 1. Alright, so then we kind of did this, which is good. We saved half of the iterations. Although I think it's still timed out because we don't have a problem here we don't have a big problem here. We have a problem here. Okay, so the triangle number. Triangle number. We are recreating always the sum, but we don't have to. The triangle number should be here, I. No, let's make it 0. And here we're going to the triangle number will be plus equals I. Oh, okay, so not const. So here we're just adding, and we don't need this function because, well, by default we have 0, then it goes here, it will be 1 because, well, for 1 we have 1, but when we have 2, the number 2, we have 1 already, and we add 2. When we have 3, we have 1 plus 2, which is 3, and we add 3. So that's good. Increment, oh well, no comments. I don't have a mind now for comments. I plus plus. I guess we could do I plus plus here. Yeah, oh well, let's leave it like this just to make it be better. Okay, so yeah, this is it. Although I don't like this while through loop. But how many times do we need to loop? We could move these divisors outside. Let's do that. Const divisors will be an empty array, and we're going to check this. While divisors.length is less than or equal to n, we're going to do this. Now we save a couple of, well, it basically will loop the same amount of times, but at least we don't have a while through. And here, well, we could read only. Okay, let. Yeah. Although I kind of like the while through there, but yeah. No, it's not the best. Sometimes. Push number. Or we could do something like, let's see, number. Or, wait, divisors dot, I forgot the method. Concat number. Yeah, so don't do the push there. So we start with one. Oh, you know what? Let's do something else here. If we're going to do the check here. If number is 1, we want to return divisors. Okay. Otherwise, we're going to do this. Yet, let's see. Still works. Timed out. Well, I didn't check. You like while through too. We had it working, right? Did I break something? What happened? I totally forgot if I had it working or not. Yeah, concat shouldn't matter that much though. Let's see. 23 works. 167 potential infinite loop. Undefined. Ooh. Okay. Not good. So we still do you remember if we had it working? I kind of forgot. Yeah, probably not. So we still have an infinite, well, a timeout. So what could we do? The only thing we could improve is here, in this loop. And then we get the divisors, check the length, return the triangle. Is there a way to get the divisors by not doing a loop? Can we improve the loop? Yeah, so it is working, but it's timed out, so it's not fast enough. Oh. Yeah, we kind of don't need, you only need the length of the divisors. Get divisors length. So we don't store it in an array, we just get the length. And here we check if the length is greater than. and here the length, let length be 0. Yeah, while true. Let's make it while true again. So while true, we check the length, and here instead of doing this, we're going to return divisors dot length plus 1. Well, again, we don't need to push the array. Okay, so if number is 1, we want to return 1. If else, let's const length will be 1. And here we just increase the length plus plus. So I think all this pushing and getting from the array was hurting us. Get divisor's length. So this is a way length is read only. Okay, let undefined. So get divisor's length, we have triangle number, we go over the numbers. If it's divisible, then we improve the length and we return it. Seems legit. And well, we don't need a special case, I think. Length will be 1, and here, yeah, it won't go inside the loop. Now let's check for 5 again. 36. Okay, so something's not working right. 36. Oh, I see. We forgot here, if you remember, we added the divisors plus, we added the less number because we go up to the half of it. So we need to do length plus 1. All right, but then here, length should be 0. No. Oh, yeah, length should be 0, and I should be 1, and should be, yeah, okay, good. So length 0, and we start with I1, and then we add 1 at the end. There is something about the divisors. What? Let's see now. We changed to an array, well, from an array, so we're not working with an array, but still, it might probably be too much. Well, we have the right answer there. Do we have for 23? We have. Do we have for 167? We have undefined. Probably because it's an infinite loop, and oh well, it will just break out of it. So I think we need a way to get all the divisors of a number. So Google, please help us. Get all divisors of a number. Let's see. Do we have some kind of formula we could use? Let's see what Lauren says in the meantime. I guess I could just say formula. If it's a loop, you're not interested. If I look at 28, let's see what Lauren says. If you look at 28, I see the first 3 divisors are important. 1, 2, and 4. The others calculated by, yeah. But what about the next one, which will be 36? What's 36 divisors? So 36 will be 1, 2, 3, 4, 6, 10, no, 10, 12, 18. Right? These should be, right? The divisors. 5 is not, 7, 8 is not. Oh, 9, we have 9. 9 divided by 4. 12, 18. They're always couples. Okay, I see what you mean. Here we have 2, 4, 6, 8. But how do we know? What's the... Let's see. Well, let's go to 45. We have 1, 3, 5, 15, and 45. I missed something, right? No. You say n divided by I. My eyes hurt. Wait, so 45 here. 120 approximately 2.14 n divided by I. Okay, my head hurts now. 39. So yeah, you see here we don't have, like you said, pairs, right? Oh, we have 9. So we have pairs. n divided by I. N, which will be 40. No. But what's the n? N is the one we received, you say? Or oh. So here, if I is a divisor, then you add I and I divided by... Yeah. Oh, I think I see what you mean. So here, we don't need to get... so... And then we need to go like only over 3. So the square root, what's the square root of? Yeah, we get 7. So I see if we have 1, we have n divided by 128. If we have 2, we have n divided 14. If we have 4, we have n divided 7. But what's the condition? We go up to what? Square root, the square root of 28. What's the square root of 28? Mad at square root 28. 5. Whoa, yay, we can do that. So, so here we can go up to, let's check that, square root of a number, and we can do plus equals 2. So here, what was the function? This, and we need to pass in what? 5. Okay, so it kind of works, and now we're dropping a lot. Whoa, this is very nice. Why did I think that the square root of 28 is 9? It's 5, so it goes up to half of them. Square root of 21 is, I'll get this, 4 and a bit. Yeah, so I think this solves it. Yeah, now you can't say now that I couldn't done this without you. Well, I would have done Well, yeah, I wouldn't want to look over some code, so I didn't want to cheat looking over code. I wanted to cheat looking over math. But yeah, that's a very good point. We dropped from going up to the half of the number up to the square root, which is huge. And yeah, we kind of need to do the same thing, but here we just add 2. I'm not sure why we need to do this, but oh well. Yeah, let's run this, see it work, submit, and be done with it. If numbers modulus I is 0, add I and the number. Yeah, we don't have the divisor array anymore. We change it to... No. You wanted to do something. We lost everything. Yeah, freeCodeCamp, you should store my solution. Oh, wait. Maybe I go here, portfolio, this? Yeah. Oops. Yeah, we don't have it anymore. Well. Yeah, it was pretty fun, although hard sometimes. Alright, thank you all for watching this, for listening. I really hope you enjoyed it. If you enjoyed it, give this video a like. And don't forget, we're going live every Wednesday. So come back in next Wednesday, where we're going to attempt to do more of this. And when we're going to get stuck sometimes, which hopefully it won't happen. We want to get to 100, but I honestly don't think I can do it up to 100. Maybe only with your help. But yeah, come back in every Wednesday, and we're going to continue. Also, let's see, there's a button saying download below to run the tests. Wait, what? Where? I'm not sure what you mean. Lauren. So the download button? Yeah, I don't see it. Alright. Okay. Thanks all for watching. If you want to check out my channel free, I have a link in the description of this video. We are doing all kind of stuff there, coding, JavaScript, CSS, React, and all that. And yeah, I'll see you next week here on the freeCodeCamp YouTube channel, where we're going to continue this series. Have a great day, and I'll see you next time. Bye!